Welcome to Unit 2, Part 3. Today we're going to talk about page replacement. So let's just review that you need to have all of your code into memory in order for it to execute. But paging helps to manage your memory so that you don't have to put your entire large process into memory. You'll only need to put the parts of the process into memory that you need in the form of pages. And this way you can execute partially loaded programs. And your programs can be larger than your actual physical memory or larger than the physical memory that's allocated to your program. For example, you can have a process that has, 100 frames and give 100 pages and give 10 frames to that process, and that process has to keep using those 10 frames. Or you can give more, or you can use frames that belong to other processes, and we will be discussing that shortly. So in virtual memory, you just take your logical process, your virtual process, and your operating system creates a contiguous representation of that process and either breaks it up into equal-sized pieces called pages or segments. And then as needed, or maybe in anticipation, those segments or those pages are actually mapped into physical memory. And then you can, if you are still running your process, you can also use a medium-term scheduler or a swapper in your system to swap some of those pages or segments out of memory and into a backing store, so processes don't need to be restarted. They can just be restarted at the particular instruction within the page or segment that has been swapped out. So what can happen in paging is if a page is not in a frame, it's called a page fault. And so what that means is that the page was either in a frame at some point, or now that page has been replaced, or that page has never been in a frame. And so in your page table, there would be a bit to indicate whether the page that's in the frame is valid or invalid. And so not only does your operating system have to deal with pages that are in frames, but it has to deal with pages that are not in frames and put them into frames. It has to check the free frame list, find a free frame, put the page into a frame, and deal with that. So here are just some examples of the amount of overhead that is involved in dealing with a page fault. Remember, a page fault is when a page is not in a frame or may have been in a frame before but is no longer valid because the page has been replaced. So let's talk now about demand paging. Demand paging is a technique that is used to bring pages into frames as they are needed. So you can have full demand paging, which means that you just start your process and you don't start anything, and as soon as you need an instruction, your operating system has to address the page fault, put the page into a frame, and then you run your process. As soon as you need an instruction that's on another page, it has to go generate the logical address for that next instruction on that page, put that page into a frame, generate the physical address of that instruction, and so on. So demand paging means that you'd only put the pages into memory on demand as needed. You don't pre-page or put any pages ahead of time. So in demand paging, for pure demand paging is, like I said, nothing is pre-paged. Everything is put in only on demand as needed. And you use a bit instead of actually doing it. Once a page has been replaced, you just change one bit on the page table to invalid to indicate that that page is no longer in a frame and is no longer valid. And you can use a secondary device for swapping pages into a backing store. So again, this is the same thing repeated, just written out in steps. You find a free frame. If you have a free frame, then you use the free frame. If you have no free frame, then you need to select a victim page to be replaced, and then you need to, if the other bit, which I went over in the other video on your page table, you have some bits. You have a valid bit and you have a modified bit or a dirty bit. And a modified bit indicates if while the page was in a frame, if it had been modified, because if it has been modified, then you have to make sure that you write back to disk the modified information, because sometimes the page that was modified, you want to make sure that if you're replacing it, that the next time you go to use that page, you use the modified page and not the one that was not modified. So here is just a visual of that. You have your physical memory and you have frames. And so you need your page, and if it's not valid, you need to find a free frame, select a victim. If you don't have a free frame, replace that frame and then mark it as invalid so that you don't try to access that frame again and think it's a different page that was there. And then this is just a diagram of swapping as well. So the last thing I want to talk about in this section is global versus local allocation. So in global replacement, that means that when you go to replace a page and select a victim, you don't select only from pages that are of the same process. You can actually take pages from other processes that may not be as active, may not have as high a priority, but you're able to get more tasks done usually in the system because you're not only using your own frames to be replaced, you are globally replacing frames. In local replacement, that means that, like I said before, if a process has, say, 100 pages, your operating system used some type of allocation method to say, okay, that process with 100 pages is going to get 10 frames. So every time that process needs to replace a page, or it's going to have to select a victim from its own frames. It's going to have to replace one of its own pages. Global, it could take from another process. And we will be doing some page replacement algorithms that are based on demand paging and local page replacement. So that concludes part 3, just some definitions about global page replacement versus local page replacement. The concept of a page fault, that means that the page is not in a frame, or that the page may have been in a frame at one time, but the page is no longer valid in a frame. And so a little bit about swapping. And in the next video, we will be doing some page replacement algorithms. Thank you.